Welcome to the second part of our conversation with Glenn Bell.
Thank you, Daniel, for having me back. I enjoyed
Yeah.
part one very much.
Yeah. So Glenn, when you look back on your career and all the projects that you have been a part of, could you share about your three projects that you have had like ground shaking breakthrough in the industry, or the projects that have been close to you during your defining career?
Sure, yeah. I'm going to focus on the ones that I feel are career defining for me.
Yes.
I'll avoid the presumption that they were groundbreaking. That's for others to judge. But in
Yes.
terms of career defining, and many of these were earlier in my career. I've mentioned a couple of them, but I'll mention them again and talk to you about why I thought they were career
Yes.
defining. The first was Spaceship Earth, the geodesic sphere at Walt Disney World Epcot Center.
Yes.
You know, that was the first full geodesic sphere ever built, supported off the ground on 6 legs. I got to work on that with Frank Heger, the Heger of Simpson Gumpertz Heger, who was absolutely and unequivocally an engineering genius. So that was a great opportunity to work on that with him. So we had to figure out how to support this sphere off the ground on 6 legs. I think you can appreciate that sphere and shell type structures don't like point supports, right?
Yes.
So how do you do that was a big challenge for us. We also, by the way, I want to mention that at the time, and this was around late 70s and early 80s, we're still relatively primitive in our ability to apply computer methodology. Still, most analyses were being done on mainframes. The PC hadn't been invented yet. There were limitations. Machine time was expensive, and there were limitations on the size of core and so forth. So, you know, you had to watch out how many degrees of freedom were in your model. So we did a lot of that work by hand. It was the first project really that I worked on that drew large-scale national attention. I learned a lot about innovation. I learned a lot about working with some really creative people at Disney. That was really fantastic. And it was also a project that was extraordinarily well managed, probably the best from the owner's perspective and support, and the CM all the way down the line through all of the sub-consultants and contractors. So it was really well done. So that was a great experience. And I was relatively young working on that. I mentioned the Hyatt Regency failure, 1981. That was a game changer for me in terms of understanding our obligation to public safety and how badly things can go wrong when they do go wrong. So it got me into forensic engineering, but it also set me on an industry push to try to improve the profession by learning from failures. So I got involved in some ASCE activities, the Committee on Forensic Engineering. I was one of the co-founders of the Technical Council on Forensic Engineering. We started a new journal of case studies in ASCE, and that work in learning from failures continues to this day. You mentioned in the introduction the confidential reporting on structural safety scheme that we just started up. That continues my passion and commitment to learning from failures. And then the third project I think I would mention that was career defining. It was really more of a program than an individual project, but I did a lot of seismic consulting with a Fortune 500 company, Procter & Gamble. P&G had some pretty significant damage to structures that they owned and or leased in Northridge in 1994, and then Kobe in 1995. And we were tasked, and I was part of going out to a team to do damage assessment, figuring out what went wrong, etc. And that caused P&G to undertake a corporate program worldwide to do seismic risk assessments of their facilities around the world. And one of the first things that we did was plotted all of their major facilities on a world map. And if you overlaid that on regions of high seismicity, there were very strong correlations and overlaps there. So there
Okay.
were a lot of places where, we went to work to evaluate and then reduce the seismic risk. The important part of that work for me, there were two aspects of it. One is it gave me a really strong global perspective of
Yes.
design and construction practices around the world. We did
Yes.
work everywhere for P&G, but we also got to interface with the very top levels of corporate management when it came to risk assessment and what the impact was, say, of a seismic event taking down a manufacturing facility on their supply chain and processes. So I learned to see, the work that structural engineers do from a much broader perspective there.
Okay. Those are some great projects that you mentioned. Just to follow up on that, like
Yeah.
which has been the most technically challenging project that you have worked on in your career, right?
Wow.
And why was it challenging?
Okay. I'll mention two that I worked on near the end of my career. The first was participating on the SGH's team working for NIST on the
Okay.
progressive collapse analyses of World Trade Center Towers 1 and 2. The overall program, by the way, was to describe and do a progressive collapse analysis, the reasons for the failures of the Twin Towers, how it happened,
Yes.
and why. And we were part of a team of really three organizations. NIST was the overall the client. They had done the fire modeling and sent us as the progressive collapse engineers the temperature time histories that resulted from the fire modeling. And another firm, ARA, Applied Research Associates, did the airline impact of the structures, and that set the initial structural conditions for our progressive collapse analysis. So our job at SGH was to take the work from NIST in the temperature time history, ARA, the initial structural conditions, and then carry that through to a step-by-step, progressive collapse analysis. At the time, we did the analysis in ANSYS. We were pushing all of the software and the modeling to its boundaries and beyond, using explicit and implicit methods, combinations of the two, literally going into the software with ANSYS and making changes, developing our own elements and things like that. It was a tough project. And a single run of a progressive collapse analysis took over 2 weeks on at the time, the most powerful computer clusters at the time. So that was a tough project and really, really demanding. The other one I wanted to mention was the final design project I worked on. Not final, but one of the final at SGH, and that was the Baha'i Temple of South America, which was built, completed not that long ago,
Yes.
outside Santiago, Chile.
Yes.
Very beautiful, unusual structure, really daring and lovely design concept by the architect, but very challenging in that it was built at a high seismic zone. It used some new materials for the cladding that had never been used before. Extraordinarily tough geometry, precision required, and the owner wanted a long design life. So we used every resource, every technical resource that SGH had in structural design, structural analysis, materials technology, thermal analysis, weather enclosure design, temperature analysis, probabilistic methods in Baha'i Temple. And that was, it was an exciting and fun project.
That's great. That's great. According to you, Glenn, is there any aspect in which our structural engineering or the construction industry is lagging behind in terms of technological advancement? Like, what do you feel should have been already incorporated in our field technologically that would have brought in a revolution in our design process already? Like, what are
Okay.
your thoughts on that?
Another great question, and it really goes to our future. I think we've done a really good job of developing technology. We've done great things with digital tools. Where we're really lagging is in the application or the uptake of that technology in the real world. And I think that that's felt most strongly. To me, the largest missed opportunity to date has been in missing the ability to use digital tools in a seamless way through the design and construction process. That is, use them as a tool for conceptual design, design development through final analysis and design, and then very importantly, to be able to transition those digital models into the built environment through manufacturing and fabrication and then construction. We really should be able to use tools to conceive the project, develop the project, define it, literally build a building or whatever the structure is in digital space.
Yes.
And then use automation to take that digital model and make it a physical reality. That's the dream. We could do so much. And the barriers so far really are not organizational, they're technological. We work in a very fragmented industry where there are a lot of players that don't necessarily always work together in an integrated way. And that's what we're working on. Through various tools, we're trying to break down some of the legal and organizational barriers. Concepts continue to develop with integrated project delivery and design build methodology and things like that. So we're doing pretty well on the development of the technology, but we're still catching up in optimizing the application of it.
Yeah. My last question for you is, like, one of the future's vision of the SEI has been to attract and retain the best and the brightest students to our profession in order to have a strong future for the structural engineering profession. Like, it's commendable to see how the committee has laid out a roadmap of the things that are needed to be done to reposition ourselves as an industry and produce leaders. But one of the major concerns, because of which many of the structural engineers look for options to change their profession or make a switch by considering for an MBA, is due to a large gap in the pay compensation. So what are your views on this topic, and how can we as a profession work towards reducing this gap in the salary compared to other professions?
Good, great. So I'm going to get to the question of the pay gap and what we can do about it soon, but I want to just make a couple of preliminary comments, which I hope will be useful. I don't think that the pay gap is necessarily as large as sometimes people think it is, because a lot of the times it depends at what stage of the career you're talking about. It may be largest, earlier in your career, maybe 3 to 5 years out, because a lot of younger engineers with MBAs are put on a faster track with a shorter term and higher salary when some things take more time to learn and develop in structural engineering. But the opportunities in the more business tech-oriented don't necessarily have the same sustainability as civil and structural engineering might do. I had a number of engineers in my time at SGH who left the company to go to the tech industry. Some of them got MBAs. A lot of them came back because their industries and their firms fell on hard economic times. So, honestly, I think if you look at structural engineering over the long term, you can earn a very good salary in a career that's relatively stable over the long term. So I just want to offer that because I've always told people that I mentor that taking the long view is the most important thing. It's hard to do when you're 25 years old, but it's worth thinking about.
That was one of your views that you kept in mind while selecting your major and bachelor's as
I
well,
did.
keeping in
I did.
mind that you have a long, stable career.
Right. And I wouldn't have traded that opportunity up for anything. The other thing I think people need to think about is money is certainly important, but there are other things that are important in your careers as well. And for civil and structural engineering, I think one of those is the opportunity to truly make a difference in the world. And I know this is something that really resonates with the younger generation. Two of my three, grown kids are engineers, and they went into engineering to make a difference in the world. Our opportunity as structural and civil engineers to make, to provide stable, resilient, and safe environments and infrastructure for people, that's something that's very satisfying and something to be proud of. So those are just two preliminary comments to your question that I had to get out there. Now back to the money. Should we and can we make more money in structural engineers than we do? The answer is absolutely yes. But we have to advocate as an industry for ourselves to do more for industry. And that means to alter basically our value proposition to be able to provide more value in the minds of our clients. And this goes back a little bit to what we were talking about earlier in part one, Daniel, about the prescriptive nature of our business in structural engineering and the fact that machines have been taking over more and more of the number crunching. As time goes on, the impact of that is that we become more commoditized because if we allow ourselves to just be the exercisers of programs, that computer programs, software that solve the equations that are in these overly complex codes, then where's the creativity? Where's the value? We really become commoditized. And the short answer to your question is that we have to reverse that commoditization. We need to shift our effort way back to the earlier part of the design spectrum to be working more in the creative aspect of conceptual design, where we're doing option analysis, looking at innovation in materials and systems. And we also have to work ourselves in a position to be trusted advisors and leaders for our clients. This is where we can create the value. And everything about, the structural engineering vision by SEI is about positioning ourselves for that. And we're doing a lot to move the profession in that direction.
Yes. So that brings us to the end of our question segment. Let's move on to our next segment where we'll be exploring Glenn's imagination and gain a few takeaways from his learnings. In this segment, I'll be asking the stalwart to roughly sketch up an imaginary building, bridge, special structure, concept or technology that they desire should be designed or available in the future. Like, the stalwart does not have to worry about any of the structural, material or technological or construction constraints about the design at this point. They just have to sketch up out their imagination on a piece of paper. So let's check out what Glenn has sketched up for us today.
This is an unusual approach, but it was in my imagination as I was thinking about this. I was imagining the future of structural engineering, which we just talked about. And this is my sketch. Can you see it?
Yes.
All right. So what I'm showing here is a group involved in the process of creating a sustainable and resilient community. And there are a bunch of players working around a table in a collaborative process. And you may not be able to read all of the writing, but there's a structural engineer. She's in the middle of the table there.
Yes.
There's an architect. There's a community planner. There's a sociologist. There's a mayor. And they're sitting around this table conceiving a resilient community. And you can see from the cloud the idea and the concept that's in the structural engineer's mind. This is
Yes.
my idea of what structural engineering should be in the future, with the engineer working, as we say, with a seat at the big table and having the skill and respect and position to work with all of the key stakeholders in the process. And they're creating here a regenerative community that is really the design is very sociological based, and it is very touching lightly to the earth, if you will.
Yes. That's a great imagination, Glenn. Hopefully, it's a reality soon in the near future.
That's my dream. By the way, the sketch is not highly polished. I intended to start with an outline and then make it better, but by the time I finished, I said, it's really more authentic to show you my initial sketching.
That's totally fine. That's totally
That's
fine.
the way good sketching works.
Yeah, yeah. Glenn, as a takeaway for all our listeners on this show, could you share a rule of thumb that you have developed or followed during your career that might help our fellow engineers in the community to keep in mind while designing or analyzing structures?
Sure, sure. I'm going to offer actually three of my favorites here that I have used and used all the time. And the first of these is probably fairly well understood, but I mention it again because it's the most powerful. And that has to do with span to depth ratios of framing elements. Steel beams typically are sized with a depth that is L divided by 24, where L is the span. Girders, L over 15, something like that. Pre-stressed concrete slabs tend to be the limit at about L over 40. But I did a lot of peer review and checking in my days, and someone with experience and rules of thumb like these in their back pocket can do a lot in terms of both conceptual design and reviewing a structure. Another one that was really powerful, and I think it's been lost in time, is the simple approximate equation for the area of steel for a flexural element in reinforced concrete, which is the area of steel is very close to mu, the ultimate moment, divided by 4d, where d is the depth. So mu is in kip feet, d is in depth. And this is for 60 KSI steel. That simple equation, you don't even need a calculator. You can do it in your head most of the time.
Yes.
Approximates the area of steel. Another one that I used a lot, and if you pull out your steel manual, you can check this. If you want to estimate the section modulus of a wide flange steel section, multiply the weight times the depth and divide by 11. 11 is pretty easy to do. Just divide by 10 and take 10% off in your head, right?
Yes.
And that will get you very close to the section modulus. So I used to use both the latter two of these in the field or in meetings all the time when I had to do approximate analyses or solutions without a steel manual or even a calculator with me.
Those are some great thumb rules that you mentioned.
Great. Thank you.
Glenn, thank you so much for coming on the show and sharing your great insights that you have with us. Also, thank you for all the service that you have done for our structural engineering community. You are truly an inspiration for many of us. I hope you enjoyed being on this show. And do you have any final thoughts?
Just that I think it's a really exciting time to be going into structural engineering. As successful as my career has been over the last 45 years, I really wish I was starting out today, because if you look at the challenges that society is facing today with climate change and population growth and the need for resilience and the move towards more human-centered design, I think this all begs for structural engineering leadership like never before. We're making great advances in areas like performance-based design and reforming engineering education and so forth. So I'm envious of those of you who are entering the career or at the early stages. So best of luck to everybody watching here. And Daniel, thank you again for your vision for the Structural Stalwarts series and for inviting me to be part of it.
It was a pleasure, Glenn. It was a pleasure.
Thank you.
Thank you very much, everyone, for watching this video. Make sure you like, share, and comment your thoughts and questions on this video. Type in any questions that you may want to ask Glenn in the comments below, and he'll be personally answering 3 most interesting questions among them. And also make sure to subscribe to this channel to help us grow our structural engineering community. Thank you very much.
Thank you, Daniel. I look forward to it.